All right, welcome back, everybody. We're going to do a draw all possible isomers from a formula problem. In this case, all possible isomers of C4H11N. I'm only going to draw one isomer with all the bonds showing. And you don't have to draw any isomers with all the bonds showing, because I'm going to immediately convert that one to a stick figure and do stick figures from that on. You do not want to be drawing all the bonds during this problem. Half the time you're wasting. Okay, let's not waste time. Time's money. And C4H11N. So, hey, what's my strategy on this problem in general? Because they always show up, and we have a question in the back. He's got an answer and he wants to check. I will check it out quick. Okay, that's a good one. It's octet violation. Oh, yes, and 5 and so that's 3 bonds in the little pair. So invariable. There we are. Thank you. All right, we got him straight, and it's going to be looking like this, because his strategy to start was the same as mine. I like putting all the C's in a row for the simplest molecule. And then whatever I didn't cover with C's, I put on the end. And then I know my nature of molecules, right? Nature of atoms. That's 3 H's on the end. You don't have to draw the bonds. Here, you can short form it like this. Verify you have the right number of H's, 3, 5, 7, 9, 11. That's one of your molecules. Okay, that took, I don't know, 20 seconds to draw that thing, probably, ish. I'll redraw it right now. Done, took 2.5 seconds. Okay, what do you prefer, 2.5 or 20? 2.5, and when the molecules get bigger, that difference starts expanding, doesn't it? So there's the first one. Can you verify that's a CH3 on the end? Yes, you can. 1 bond showing, 3 missing. That's a carbon. You're allowed to have them missing. There's 3 H's. 2 bonds showing, 2 H's missing. 2 bonds showing, 2 H's missing. Same story here. Nitrogen, you have to show the H's on the end. You can't skip them. There they are. So that's one. Now, did that NH2 have to be on the end is my next question. And the answer, of course, is no. You can draw 4 carbons in a row, again, and stick the NH2 off the second carbon. Let's do that. And NH2 here. And I'm going to draw another one where I move it in one more, but I'm going to quickly erase it or say it's not a new molecule. That is not a new molecule. Not new. Scribble it out. Tell me why it's not a new molecule. It's not unique. Why is it not unique? It's the same as the one I previously drew, right? Yeah. Yeah. It's got the molecules do not know forward, backwards, up, down, left, right. They don't know that. So use words to describe them exactly the same. It goes C1, C1, C2, C3, C4 with an NH2 off C2, right? Look, C1, C2, C3, C4 with an NH2 off the second carbon. I use the exact same words. And my words describe the whole molecule, didn't they? Yeah, so not unique, don't try it. Now on a test, I know sometimes time is, you're stressing a little. If you draw that extra molecule, I don't take a point off. I do exactly what I did there. I scribble it off, you don't get a point for it. It's not unique, right? So I'm not into punishment. Okay. All right, what do we got? How about, I think we're finished with 4 C's in a row, and where does the N go? But the N didn't have to be on the end either. N can make 3 bonds. It could be 3 C's if you want. 3 out of your 4. Want to do that one then? Yeah. Let's do an N with 3 C's. And where can you put the fourth one? There's only one place you can't put the fourth one. Don't do this. I'll show you why. It's not that it isn't a molecule. That's a molecule, but it's an ion. I guess molecules aren't ions technically. So don't draw that one. That's not nitrogen's normal nature when it's neutral, is it? So where it likes 3 bonds when it's neutral. And look at my molecule does not indicate a charge, does it? It just says C4H11N. It doesn't say C4H11N plus. So don't draw me C4H11 whatever. Don't draw that, which you just did by mistake. But you can put a 4th carbon on here. Pick one of those C's, stick a carbon off of it. Doesn't matter which one. You do it this way. That's cool. If you did it on one of the other ones, I mean, it's cool, but it's not unique. I'm doing the same thing, right? It's a nitrogen that has 2 CH3s and a CH2CH3. I scribbled off the second time I drew one of those. Okay, not unique.
What about H2?
I'm sorry, say it again.
What about the H2?
The CH2 is right here.
No, the H and H2.
NH2 is right here. What about it? It's got 3 bonds to nitrogen and a lone pair. We don't have to draw lone pairs in this question. Did it say Lewis? Go straight to stick figures. If you're not demanded to draw the Lewis, you're not commanded, then you draw stick figures. Good question.
The oxygen has
2 bonds, 2 lone pairs.
2 bonds, 2 lone pairs. The nitrogen, 1.
3 bonds, 1 lone pair. Remember, they go in order from carbon, which has the 4 bonds. So next one over, 3 bonds. Next one over, 2 bonds. Next one over, 1 bond. Fill in the octets with the lone pairs. What? Oh, yeah. Okay, second one coming up. All right, we are not done. Nitrogen doesn't have to have 3 carbons, does it? No, it can have 2 and an H. We haven't done any of those, have we? No. N has an H and 2 C's. I think I can get a couple molecules out of this, because that's only 2 C's so far. I need how many more? 2 more. I could put them both on the same carbon. And that's not even the only way to do that. Watch. I could have put them like that on the same. Oh, that's different, isn't it? There's 3 carbons on that nitrogen on the bottom. And so are there here, but they're in a different pattern, aren't they? And how about 2 carbons on each? Each of the bonds is to C and then C. Isn't that another one with 2 bonds to C and a bond to H? That's unique.
Can we double bond any of the carbon?
No, because you lose 2 H's every time you put a pi bond in. Yeah, they take the place of hydrogen in the formula. So that's why we had to verify our first structure that had 11 H's, has no pi bonds or rings. So therefore, none of your structures has pi bonds or rings. I didn't even mention rings. Rings also remove H's from the formula. They do. Okay. We have them all? The 7 molecules, 1, 2, 3, 4, 5, 6. The first one is the same here and here. Just to be clear, those are equal, right? So I'm pretty sure this is our final answer. That's all I need to see. And that's 7 structures. We did all the ones with N with 2 H's and 1 C. All the one with N with 1 H and 2 C's. And we're done. Because we got one with an N and 3 C's too. All right, that was fun. Oh, we didn't finish. We didn't finish. Can I go back? Because we didn't do the functional groups.
Can we do a C bonded to 3 CH3s and then an H.
A C bonded to 3 CH3s and an NH2? Yes. She found one I missed. Look at that. A C bonded to 3 CH3s and an NH2. And I'm thinking we may have this one already. No, that's 3 and then 4. Then that's 1, 2, 3, 4. That's 5. Never mind that one. So you've got. I think she got the one I missed. Yeah, and what just happened should not stress you out. Your goal is not to try to get them all. Try to get a lot of them. Do not be hard on yourself if you don't get them all. It's a trial and error question anyway. Hey, you missed one of the trials. Okay, that's it. This exercise is very valuable early on in this course. It is a big refresher of how atoms bond with each other. That nature of the bonding that we keep talking about needs to become part of your thinking. You know, whenever you think about carbon, you're thinking about 4 bonds and no lone pairs. That's just a baseline fundamental. Okay? And what do we got? I think we got them all, but we didn't do functional groups. That's at the end of the chapter. You might not have got there yet. That's why it's a preview. But it is chapter 1. And there are 2 functional groups in this chapter that we learn about out of our 8 functional groups. 2 of them have nitrogen. And one of them is called an amine, A-M-I-N-E. These are all amines. And if the nitrogen was attached to a carbon that had a double bond to oxygen, we call that a carbonyl. You'll be reading about it this weekend, I hope. If a nitrogen's attached to a carbonyl, it's not called a amine anymore. It's called an amide with a D. Okay? And they're very different. They have very different behavior. Okay? They each get their own chapter in the next course. That's how important they are. They're functional groups. This course is organized around the functional groups. They're like the players in the play. They have their own behavior. We have to learn them, you know, who they interact with, and what kind of things go on when they interact. Okay? So we got that, and there's a reason why this one's called a primary amine. And so is this one. And those are our, oh, there's another primary amine. What do they all have in common? Please use 1 in your answer because the primary has a 1 in front. Please try to incorporate it in your answer for why these are primary amines. What is there only 1 of in each of those 3?
No.
Okay, then everything's a primary amine.
Bonded
Bonded once to C. They're the only nitrogens there that are bonded once to C, carbon that is. Okay. Are there any secondary amines? There are 3 of them. Every primary amine that is labeled there has the nitrogen with only 1 bond to carbon. The secondary amines have the nitrogen with 2 bonds to carbon. I'm going to draw a secondary amine once, and I really suggest you try this for when you have to label something and it's on the page multiple times. Please do that. All 3 of those are secondary amines. When the nitrogen has 2 bonds to carbon, it's called a secondary amine. And what about the only one that's not labeled? What category is that?
Tertiary.
Tertiary, nice. Tertiary amine. Keep that in mind. It's from 1 degree, 2 degree, 3 degree, that's primary, secondary, tertiary. And we use that for nitrogen functional groups, amines and amides. And later on, you're going to learn a different use of primary, secondary, tertiary for alcohol. It's coming up on our next activity. And it's a different system. Here it's easy. If I just drew this And I asked you, what do you say? Oh, it's only got one bond to C, say primary. If I drew this and asked you, say, oh, it's got two bonds to C, it's secondary. It's easy, right? Just gotta know what the criteria is. Alcohol criteria is different. Because if you use the same criteria for alcohol, remember alcohol, well, maybe not remember, fact, alcohols have an OH attached to a C. If you use this system, every alcohol would be primary. What use is that system? Now, in alcohols, the carbon attached to the O is what gets classified in the same way. We'll see it very soon. And that's the end of that one. And moving on.